SIKA temperature calibrators can be used in countless applications. Whenever results need to be reproducible and high-quality standard supply, you're on the safe side with the SIKA calibrators. One example of this is the food industry. In this context, there are two special features that we would like to talk about. The special feature of the calibrators in our TP Premium series is their touch display. This makes them easier to operate, but does it also mean that the calibrator represents a potential hazard? Where glass is used, glass breakages can occur, and glass breakages are a major problem, particularly in the food industry. If the calibration takes place directly within the production line, a glass breakage may lead to the goods being contaminated with splinters. And because glass is very difficult to detect, it may even be necessary to dispose of an entire production batch. We are aware of this danger and have therefore manufactured our touchscreen using exponentially strong safety glass. In doing so, we employed the DIN EN 610101 standard, which states that a ball weighing 500 grams must not cause any breakage when falling onto the glass from a height of 1 meter. This corresponds to the IK code IK08. Following the impact of the ball, the calibrator continues to function as normal. This eliminates any danger to you or your production. And if the display should ever be damaged, it definitely won't splinter. But this isn't the only special attribute in the food industry. Let us now turn to the sensors that we want to calibrate. In this regard, we need to know which specific sensors are generally calibrated in the food industry. In this case, we will pay a visit to a dairy. Here, sensors with an aseptic connection are used. Due to the standards required within the industry, it is difficult for the user to achieve satisfactory calibration results with either a dry block or microbath calibrator. As a user, you would normally employ a calibration bath for sensors with such an exceptional geometry. In this case, the calibration is generally carried out at 121 or 131 degrees Celsius. This means that water can't be used as a calibration medium. Your options are thus limited to a calibration oil. Caution is advised, however, as the devil is in the detail. In the food industry, your goal should always be to ensure contamination-free calibration. Using a calibrating oil contradicts this basic premise since the calibrated sensors have to be cleaned afterwards, and this costs time and money. It may also be that your sensors are very short. In this case, the sensors could potentially fail to reach the homogeneous zone. Finally, the use of calibration baths harbors the risk of additional measurement errors due to the expansion of the calibration medium. The question of whether this is relevant to your specific application must be decided on a case-by-case basis. Therefore, there is much to be said in favor of using a dry block calibrator. Yet, a standard solution also reaches its limits here. We achieve the best calibration results if we use an external reference sensor. This is normally inserted into the calibration sleeve. However, the special geometry of the temperature sensor renders this impossible. The solution: a special calibration insert with a raised edge and an external reference temperature sensor that is easy to use despite the lack of space. The edge is accessed via a stepped borehole, which is adapted to the outline of the sensor. This means that the sensor is accommodated in full and measurement errors are avoided. The lateral borehole enables straightforward use of a reference sensor. Another intelligent solution from SIKA. Did you enjoy this video? Then be sure to give us a like. Do you have any questions or suggestions? Then feel free to leave us a comment. Additional interesting videos are available on our channel. We would be pleased to welcome you as a subscriber.